Hi everyone, we are back in our YouTube Percona channel. This time is for our third video in the MongoDB Operator series with Vinodh Guruji. Previously, we had Percona MongoDB Operator installation and setup in Kubernetes. You can find it here in our YouTube videos. We also had a Percona MongoDB Operator using Helm, also here. This is our third video, MongoDB config changes and handling the user management in PSMDB Operator. Hi Vinodh, tell us how have you been and more about our session today.
Hey Ed, I'm very happy to be again here for our series Percona MongoDB Operator series. And this is going to be the episode third, and we are going to talk about the user management and as well as the DB config changes in the operator, especially in the operator. Okay. And we will see in detail in the session. Wow, great. So welcome to this particular Percona MongoDB Operator series, episode 3. And as I said, I'm a support engineer in Percona, and people call me as Guruji, and I'm just another soul who wants to share things with you guys. And thank you, Ed, for arranging this video. And today we are going to look about config changes in MongoDB, especially in the operator environment and as well as the user management. Okay. And this is particularly for the operator environment. And before going into the details, you need to have a kubectl installed and you need to have enough nodes, resources, operator, and the storage. And especially we are not going to talk anything about backup, but in the coming episodes, we are going to talk about that as well.
Do we have a minimal amount of nodes that we need for this demo or for MongoDB to install MongoDB in the previous?
Yeah, for this particular demo, I'm using single node cluster because this we can easily test in our laptop or test machine itself. You don't need big resources to do this test. And especially for production, it is not recommended. You need to have enough resources, enough nodes to deploy the members in the for the cluster. And here for testing purpose, we are going to use especially a single member replica set that is for sharded replica set as well, and as well as single member for the config server replica set as well. And especially we are going to use 1.191 operator. At this point of time, 1.20.1 has been released, but still we are going to use 1.19.1. For your production, it is always recommended to use the latest available for your production. And here we are going to do test with the sharded clusters. And we are not going to talk about PBM or PMM. That is reserved for future episodes. And let us talk about user management first. Okay. And in operator environment, we have to split the user management into two categories. Okay, we are going to split them as a system level users and application level users. System level users are nothing but the users are managed by operator itself. And whatever the changes that you need to do via operator. And application level users are the users that you are creating for your application, and the extra users that you can, if you want to create extra user for some users in your team or for application for testing or whatever it is, those are all application level users that you can create and drop and change whatever you want to do with it in the database directly itself. But if you want to work with system level users, you cannot do the changes in the database directly. And if you want to, e- even if you have changed something like that, you need to reflect those changes to the operator as well. Otherwise, what will happen is operator will try to revoke those changes, uh, and it will try to bring to the state where operator knows. So that is the catch point here. And uh, if you want to see the example, for example, you can mention the application level users inside the cr.yaml as well. I said that you can create inside the database by yourself. But in another way, if you want to predefine that users while creating your cluster, you can do that as well by mentioning them in the cr.yaml as well. And to maintain the system level users, we can use secrets. And when you are creating the cluster, before creating the data pods, you need to deploy the secrets, that is system level users secrets as well. So that what happens when the pods of data nodes are created, uh, operator will impose those changes that you have created through the secrets into the database. Okay, so it is important for you to create the secret before deploying the pods, that is data pods. Okay, and if you want to mention roles, customize roles, you can do that as well. And regarding the system level users, there are 6th level users are maintained by the Percona MongoDB operator. Those are cluster monitor, database admin, cluster admin, user admin, PMM server related user, backup and restore users for PBM. Okay. And here the cluster monitor is very, very important one, because whatever the readiness check and everything is doing with the data pod by the operator is using this particular cluster monitor user. So if you are going to change this user, especially the cluster monitor user, that needs the restart of the cluster. Otherwise, what will happen? That changes will not be imposed, that is embed in the database. And other things are database admin users, cluster admin users. Database admin user is the user created for you to maintain, to do any admin works in the database. In addition to that, if you want to create your own users, you can create. You don't need to mention here. And cluster admin is the admin user which has permission, privilege to do admin works in the cluster level itself. And user admin is the user. By using this user, you can create different users. Because if you want to create some users, you cannot create users with database admin. For that, you need to use this particular user admin users to create the application level users. And if you are going to also deploy PMM along with this operator, you can use this particular PMM user as well. And as well as if you are going to take backups using operator, you can use this backup user as well.
Question.
And yeah, tell me.
Sorry. So do we need to restart also the cluster with all these users or just with cluster monitor user?
For cluster monitor, you have to restart. For other database, other admin users, you don't need to restart, but you need to apply those changes via operator.
Okay.
Okay, and here this is the sample of secrets YAML. And if you want to change the username for backup, you can change here, and you can change the password for database admin, cluster monitor, something like that. Okay, you can change whatever it is, but the operator is not going to see in the human readable format. That means like uh, what after deploying these secrets inside the database, the operator is going to convert those human readable into the base 64 encoded messages. Okay, so if you want to read those messages after deploying from the operator, you need to decode them. I will show you how in the lab session. Okay, so this is one of the after getting the secret, you can see this. When you see this particular secrets file, you can see the encoded version of password, username, password, username, password, username, password, username. Okay, and if you want to see that, you can see here that I'm decoding that password. I'm seeing the password here. So this is the password for database admin password. Okay, and if you want to do that, you can do like this, and we will see in the lab session. Okay, and Please note that before applying the before deploying the data pods, apply the secrets. And if you want to change the username password, I mean, if you want a customized password, you can change in the secrets file and then deploy that. Otherwise, operator is going to choose your password and username by on its own. And the base64 encoding is used by the operator. And if you want to change the monitor user, you need to restart cluster as well. So we will see that in the lab session quickly before moving into the next session. So I'm going to create, so here I have put alias for this kubectl
Mhm.
with K. So whatever the, instead of kubectl, I'm going to use the word K itself. So for example, K kit pods. Okay,
Great.
K kit namespaces. So I have these namespaces already. So I'm going to create a new namespace.
Could you make it a little bit bigger?
Yeah, please.
Yeah.
Uh,
One, two more, maybe. Yeah, that's amazing. Mhm.
where is it? Okay. Okay. So I'm going to create a new namespace for this one, PMDB test. Okay. So, oh, sorry. I have to mention namespace. Okay. So namespace is created and I'm going to use Percona Server Operator 19.1, especially here. And if you go to into that, if you want to download, we have GitHub project available. You can download from there. And you can see a lot of YAML files already available here. And actually, if you want to deploy the operator first, you need to deploy the CRD, RBAC, and secrets and everything. And I'm not going to deploy them one by one. For that, I'm going to use bundle.yaml. It will deploy everything needed for running the operator. For example, if you see inside the PSMDB test, nothing is there right now. And I'm going to deploy this operator
Bundle.
bundle YAML file here. Oh, sorry. It is apply command. And also you need to use server side argument so that what happens, it creates, you can see CRD is created, role binding is created, deployments are created. So if you see here, you can see the operator version is running. And if you see all, you can see the deployment replica sets are created here.
Could we see the file inside what it
Yeah.
is? Yeah.
So if you see the file, you can see the custom thing. For example, you can see that CRD. Okay, so something like that. So a lot of things are
Yeah.
mentioned here. Role binding, service account, and even apps deployments are mentioned here.
Mm.
So it's a combination of many YAML files. And now it is time to deploy the cr.yaml. But wait, before deploying the cr.yaml, you need to deploy the secrets, right? So secrets.yaml, you can see that here. And I'm going to change passwords here. So before that, I'm going to uh, uh, copy that into the different file. And I have already have a directory created works here myself. So I'm going to copy here secrets and for example work.yaml test.yaml. Okay, and let me open and change the password. We are not going to use backup, so I'm going to ignore that. And admin password db admin at 45. Okay, something like that. cluster at 1, 2, 3, 4. Cluster monitor. Thing like that. I'm leaving this. Okay. So this is the new secrets file. And I'm going to deploy this. You can see that apply F, this one, and I'm going to apply this
Namespace also.
uh, in the namespace
Mhm.
MDB test, right? Okay, great. So if you see get secrets here, you can see that name cluster is created. This is the name of the secret file. Okay, so and here I'm going to use the cr-minimal, which will have the minimum configuration, and I have configured as well already here. Okay, so that is serious inside serious I have created already. So here you can see that I'm using this 7.0.4.15 and I'm going to use single member replica set, and inside config replica set also I'm going to use single member, but the default is 3. Since I'm going to change the defaults, I need to mention that this is tell the operator that I'm going to use the different defaults for these values. So for that, you need to mention unsafe flags. Okay, replica set and as well as Mongo size, I'm going to mention 1. Okay. And here you need to know that you need to change the secret name as well, because here we have created the secret name as my cluster secret name. So that we have to give here. Then only operator will know that, okay, I need to use this particular secret deployment. Okay, so I'm going to change this. Okay, and let me apply this file, and inside PSMDB test namespace. Before that, you can get ports. You can see that only operator is there, and just apply this. So you can see here that pods are getting ready. So you can see the changes, the state with using -w. So you can see it is pulling the images, DB images. Okay, now it is going to start the database. So when it is 1/1, it is ready for you to use. Okay, so now config server is ready, and shard server is ready. And the next thing is MongoS. So once these two things are ready, MongoS will be deployed, and we will wait for it to be deployed.
The name of the file is cr-minimal.series.yaml, right?
Yeah, this is the YAML file. And like I said to you, yeah, you can see MongoS is now creating. I said to you, this is for testing purpose. I'm using my local laptop and using single node for this deployment.
Yeah.
And for production, please use the recommended size.
Mhm.
Okay, now everything is ready. You can see that without -w, you can see that everything is ready, running state without any error. Now, if you see the secrets,
Mhm.
what is the secrets now?
Mm.
Okay, so if you see that's internal is created by the operator, and it is used for currently by the operator. Okay, these are all operator, and by default operator uses SSL for communication, so it is created by its own. Key file is created for deployment of replica set. Okay, and here let me, so this is our secret, and if you see, if you want to see the content of the secret, you need to see this option give -o YAML. Okay. Once you give this, you can see this particular encoded version of base64. Okay. You cannot read them by your own eyes. Okay. So even if you see the internals, that is minimal cluster users, you can see that same thing. For example, let me take the command. Okay, so this is the whole command for looking at particular. For example, I'm going to see admin user. Okay, so if you see database admin, sorry. Okay, so you are going to see the same thing even if you are going to use the different. Okay, so both are same. So if you want to see the password, we have changed the password already, right? So
Yeah.
we are going to see our password, dbadmin45. And even with the internal minimum cluster, you're going to see the new password only that we have passed. Since we haven't changed anything to the data username, it is there already. So you have to make sure that both all are same. What happens if you see this particular uh, mm, thing, sorry. So if you see this, if it is not in running state and if it is complaining about readiness, okay, and for example, how can you see if there is something error with this particular one? Okay, for example, you can check something, describe pod name and okay, something like this. So if you see here, you can see all the events happen with this particular pod. If you see here, it has downloaded the 7.0.15 image and successfully pulled and everything is okay. And also here, if you see the readiness, the ready is equal to 2. Okay. uh, there is a concept called readiness. That is, operator will ping the database pod and check whether it is up or not. Okay, that is called readiness. And that if that is failing, then you need to first check the user password and everything. Okay, so that is the thing. And for example, if you want to see all the images that you have downloaded with your deployment, there is a command. This command you can, sorry, different command. One second, let me get that. Okay. Okay, so this is the command. So if you see here, these two images were downloaded. One is operator image, another one is 7.0.15. So immediately, if you want to see the operator version and the database version deployed in your deployment, you can use this particular command. It is very handy. You can note it down. And mm, the other thing is, um, like I said, let us check how to log in with that particular username password. Okay. So let me log in into I'm going to deploy a temporary pod. Okay. That will be having with the this particular database installed. So you will be having Mongo SH deployed there already. Okay. So here you need to know that if you are going to connect with Mongo S. Okay. So you need to pass cluster name hyphen Mongo S namespace SPC cluster dot local and database admin and database password. What is the username password that you want to give? You have to give that. Let me use the password here. We have used the password on this one here. And I think to use at the rate, you need to give some $40 that is encoded for that one. And cluster name here is minimal cluster. And the namespace is PSMDB -test. Okay, now you are connected. So you make sure that you are not using at the rate in the password. Just use the encode, character encode is there, right? And if you check the website in the Google or something, you will get the encode string for that particular at the rate, and you can use that one. Now, if I do the show DBs, I can see everything and do the operations here. Okay, so this is how you have to connect with the database. And if you want to create a username or something, you need to use the user admin and username to create your application users. Okay. Because
Yeah.
so like I said, you can connect to this database and you can do you can create any database and you can create collections, anything on that. So you can see that Vinodh is created and this particular, this is created. And if you want to see the shard status, you can see that we have single sharded cluster. Okay. And we don't have any, this, we know this not enabled with the cluster right now. So you can enable sharding here in the table thing. So that you can do on your own. So for now, let us move on to the next part. That is DB config changes.
Okay.
Okay, and this is very simple. And if you want to, there are some changes that you need the database restart and everything. For example, the white tiger cache changes. Okay, and if you want to change the concurrent tickets, okay, for the white tiger, you have to change via operator only. You cannot change it directly into the database. Okay, so how you can change those changes is, so in three ways you can do the parameter changes for MongoDB in our operator, Percona MongoDB operator. So first change is cr.yaml, second change is config map, and third one is secret object. You can use any of these three, any one of these three methods to apply the changes in the MongoDB parameters. For here in this particular lab, I'm going to use cr.yaml changes. Okay, for example, if I want to change the cache size to different, for example, one different GB, I have to give like this. Okay, if I want to change the concurrent tickets to 16, okay, you know that from 7.0 version, it is dynamic. But if you want to set to a particular number all the time, you can set that parameter like this as well. Okay, so let me show you how to do that. For example, let us see the current cache. What is the current cache size inside our deployment? For that, we need to connect to the uh, mm, database, and we will use this particular string to connect. Okay, and let me get the command to see that. So this is simple server status command, and I'm going to um, filter the cache part. Okay, maybe. Okay, Sorry, here you need to connect with the particular replica set. I have connected to the Mongo S. Mongo is the router part. We don't need to connect with the router part and check the things. Okay, so here I'm going to connect with, for example, here I'm connecting with the replica set, a shader replica set. So I'm connected with that one. And if you see here, you can see the things here. And if you see here, the maximum um, uh, uh, bytes configured. This is the bytes configured. And if you see here, 0, 0,
Yeah.
so nearly 5 GB has configured right now. Okay, and how many byte cache is filled right now? It is only currently it is barely 3 MB inside the byte cache. So let us take this value for now. How you can do this is, so this is the value right now. And you want to change, I want to allocate only 1 GB for this. Okay. As this is test server, I want to allocate only 1 GB. So how you can change this? Let us see that. So first you want, and also before going into that, let me check the concurrent transactions as well. So you can see that right now it is available is 12 and total tickets available is 12 for write 12 and read 12. And we are going to change this as 16. Okay. So that the recommended one is at least the number of your course, maybe double the number of your course, not more than that.
What is the total of tickets in this case of MongoDB?
Here it is allocated with 12. So if you want to check the number of, for example, we want to first see what is the available post info details. Okay, so if you see here, you can see that it is allocated with only 12 cores. So that is why you are seeing here 12.
Mm. Okay.
Okay, so and you can see the memory as 12 GB. So that's why you are seeing half of the memory minus 1, that is 5 GB, is allocated for Vitega cache. By default, MongoDB allocates 50% minus 1 GB of your RAM size. Okay, so let me go and do the changes in the cr.yaml. Okay, so what is the cr.yaml we have used?
Minimal.
Serious, right? So here I'm going to change only for the replica set. Okay, I'm not going to change for the config server. So we can compare that how that is going to work. So let me, I have already copied and kept it somewhere. Okay, so that you can, like shown here, you need to put it down under name. Okay. So this is the one you need to make sure that you are adjusting the,
Indentation.
yeah, 1, 2, 3, 4. Okay. 1, 4.
Mhm.
Okay, so it has to look like this. 2, 3, 4, 5, 6. Okay, then correct. Okay, so here I'm going to keep 2 GB for replica set of shard one, and I'm not going to change anything for the config server replica set. Okay, I'm going to save this. Let us get this and make sure everything is fine. And this is under this one. Okay, fine. And I'm going to change this one. How I can change this one is you have to replace this one. Okay, -F with this, where you want to replace. Before that, get pods and PSMDB test. For which one you are changing this? Replace -F works. CR minimum serious. Okay. So I'm going to do this. So I'm going to force this as well. I don't want to wait anything. I don't. So just do this replace. Okay. You can see that it is deleted and replaced. So once immediately, if you go there, you can see that it is terminating and restarting everything. Okay. Wait for that initiating. Because we have deleted and changed everything. Yeah, but the catch here is Mongo S will go down once it doesn't reach anything with the config server. Because here config server also it is getting recreated. So because we are deleting everything and creating everything,
Mhm.
but we are not deleting the data because PVC is there already.
Mhm.
It is created already. So Mongo S is created. So that means everything is ready right now. So you can see everything is there. So let me connect to this one quickly.
Mhm.
I'm connecting to the replica set of sharded cluster, and I'm going to use the same command, but let me check whether it is okay. You can see 2 GB. It is changed right now. Okay, and if you want to see the concurrent connections, sorry, concurrent transactions, you can see it is 16 right now. Earlier it was 12.
Yes. Mhm.
But let me go into CFG, that is config server replica set. And if you see the cache, it's different because we haven't changed anything there. You can see 12 and
Mhm.
you can see the config server 5 GB. Okay, so this is how you are going to do the changes in the database. And other two ways are config. You can use config map or secret object that is available in our documentation. You can use that as well.
Mhm.
Thank you.
Oh,
So if you have any
to
questions,
summarize this, we installed the bundle of our operator. You can find our Percona server for MongoDB operator in our GitHub repo. You will find it here in GitHub. And what we did is clone the project, right? You clone the project, we install the bundle who contains all the resources for this demo. Then we change the secrets, we modify some passwords, and we apply the secret in our new namespaces. And then we create and apply the custom resource where we also change some configurations for the replica set, correct?
yeah, sharded replica set.
Okay. Nice, amazing.
Uh,
Thank you.
no, it is always recommended in production environments. You can use the secret file way of applying the database changes as well because when you are using that secrets file method you are going to encode everything into the base 64 and you cannot read the changes directly, but also config map is also a way to apply the changes of the DB parameters, so you can use both ways as well. And cr.yaml is the direct way of applying the changes. If you want to apply simply and easily, you can use the cr.yaml way of applying the changes.
Okay, I have some questions. What are the common use cases from people to change the configurations on PSMDB?
Yeah, well, commonly people use config map because it is also one of the way to apply the changes. And the people face changes a lot with user management because as far as I have seen, people they want to change something password or something with the users, and they directly go to the user database and they change the password of the database. For example, the monitor cluster monitor user, they change when they change that password. What happens, operator cannot connect with the, it cannot ping and then check the status of the database pod. So in that case, the pod continuously gets restarted, and the customer comes to us and asks like, they tried changing the database or they forgot the password with their user, so they change the password. Now they are not able to see the pod is stable or something. It is getting restarted automatically. So these are all the common mistakes done by the customers because uh, the proper way to do the changes is changing in the username. For example, here I haven't, maybe I haven't showed you the proper way. Okay, the proper way is getting using the patches. Okay, for example, here if you want to change something with the user secret, um, sorry, not here. Custom operators application. Okay, here. So if you see here, if you want to change some user system users, you have to use this patch command. So earlier we were using db at the rate of admin at 45 something password we were using. But if you want to change that, and how you can change after deploying the secrets, you
Mhm.
have to use this patch command. Okay, if you use this patch command, immediately you can see the changes inside the database as well.
That is gonna restart the cluster, the database? No, it's gonna.
No, but if you are going to change the cluster monitor, it will restart the cluster. But
Mm,
if you are going to change the database admin password, it is not going to do the restart.
got it.
Okay, so this is very easy way for you to change the
Mhm.
password.
Yeah. In this case, in this example, we saw use we changed some configurations files for one replica set. What and how is how is the behavior for the operator when we have more than one replica set? Do we have to change several
No,
parts?
no, 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 no. See, the main thing is you are going to apply the changes in the replica set level,
Yeah.
and the operator will understand that you are changing something in the replica set level, and it will apply those changes to the replica set level. So whatever the members under that replica set, all will be changed at the same time.
Mhm.
So it is not for the particular member, it is going to change. You don't need to restart particular member or something like that. Operator will take care of, that is the specialty of operator. Operator will take care of the changes when you do the changes in the proper way. So operator will do the changes in on its own, and it will change, it will apply the changes to the shard replica set. And if you have the changes for the config replica set, it will apply for the member, all the members in the config replica set as well.
Mhm. Okay, even easier.
Yeah, yeah.
And how about security? Can we enforce security best practices? What are the common use cases as well?
Yeah, please make sure that you have customized password for all these system users, and also don't let application users to have the system level user information to them. So for them, create another user and give it to them with the proper privileges. For example, uh, admin use the application database. Uh, uh, user doesn't need a privilege on the admin database. So you can restrict that particular privilege to the application users, only give privilege to read or write into the database, application databases. And you can also restrict based on the roles. For example, the sales guy doesn't need the write privilege. They just need to read. Okay, so if they need to read something, they don't need to read all the collections in the databases. They need to read only the particular collection. So you can give privilege to that particular collection to the with the read privilege to that particular guy. Okay, for the marketing guy, they just need to get some information out of your database. They don't need to change anything into the changes. Those changes has to come via the application user who has eligible to change the data. For them, you give read write changes, privileges. Okay, so likewise, you can do the changes. So like I said, you can use the secret object way. So you can see that encoding all the MongoDB conf and then applying that as a secret, and then that will be applied into the cluster. And if you use the config map, you can create a separate config map for that particular resource type. For you have to be careful with the resource name, because with RS0 it will apply for the SHADA clusters. With the CFG it will apply to the config replica sets. So you need to create proper name for this config map, so that those changes will be applied to the particular replica set. So this is simple as.
Okay, so everything is in the documentation. I have one last question, Vinod.
Yeah.
I know you say it in the video, but what happens if I make manual configuration changes in the MongoDB directly?
What happens? One thing is you cannot log in with that uh, operator level. It will look for that particular username, password with a password. It knows when it fails. There are chances that pods get restarted again and again. So in that case, for example, if you are changing the backup username password, it won't restart the pods. But you need to make sure that when backup will fail, because you have changed the password of backup user inside the database, but operator doesn't know the changes in the password. So your backups will fail. So for that, you need to either sync the password that is in the operator to the database, or else if you want to if you want to change the password in the operator for sure, then you need to apply the changes in the operator level. For that, you need to patch the operator, and then you need to try changing the operator in that patching way. If that patching way doesn't work, you need to apply manually the secret again into the operator. So that is a two-way changes, but that will take, you need to first, um, for example, here, you need to apply change in the internal level as well, and also in the minimum cluster level as well. That is you applied the secret, right? So that level as well, you need to change both level as well. So it is a very difficult to change after you changing in the database. So it is always recommended you to change via patch method.
That was my last question. Thank you so much, Vinod, for your time and for sharing your knowledge. I hope we have a four video soon. What could be the topic, by the way? Could we get some spoiler?
Well, yeah, we have to check the backups and restore, how to take the backup and how to restore them, because that is a big challenges nowadays for every DBS that are managing their operators. And we will see how to deploy the monitoring as well for your database if you are having the operator, and also some troubleshooting things what happens. I told you, right? The readiness check. What happens if
Uh-huh.
the readiness checks fails? How to maintain the, how to bring back your pod, and how to for example, if you want to initial do the initial sync again, how you can delete your database and how you can do the initial sync again. So those things you can see in the coming videos. The troubleshooting things, backup things, restore things, monitoring things. So those things we'll be seeing ahead.
Amazing. Okay, so don't forget to visit our documentation in docs.percona.com, Percona Operator for MongoDB, and also our GitHub repo in GitHub. We are as a Percona Server for MongoDB Operator. So to learn more about how to run databases on MongoDB using the operators, especially with Percona operators for MongoDB. And also you can connect with Vinodh. I'm sharing his LinkedIn profile. I think that's all, Vinod. Would you like to say some words?
Yeah, thank you guys for your support and every feedback given for this series. And that has motivated us to go for another episode and keep us motivated always. And if you have any doubts or questions or something, please leave your comments in the comment section. We will check and reply to you. And thanks, Edith, for helping and bringing this episode out to the to every users in the world.
Yeah, thank you. Until the next time. See ya.
Bye bye.
Bye.